Bismillahirrahmanirrahim. So let us find out the Laplace transform of a unit impulse function. So let's first define the unit impulse function. Unit impulse function is defined as del t, and this is equal to plus infinity at t is equal to 0, right? Or we can say this is undefined at t is equal to 0, and this is 0 when t is not equal to 0, right? At t is equal to 0 this is infinity, and elsewhere it is 0. And furthermore it has a second property, its total area is 1, minus infinity to plus infinity del t dt is 1. So it can be plotted like this. We have t here, this is del t, and it goes on like this, right? And it's 0 elsewhere, and this is the origin, and we put a 1 here. But this one does not show the height, it shows that the total area is 1, right? This is area is 1 and the height is infinite. So this is a unit impulse function. And now to the Laplace transform. So the Laplace transform, which is a function of s of any function f of t, is defined as, this is single-sided Laplace transform, from 0 negative to infinity f of t e raised power minus st dt. So we substitute f of t here with del t. So Laplace transform of del t, delta function, is 0 negative to infinity del t e raised power minus st dt. So this del t function also has a sifting property. So sifting property, which we will use in evaluation of this integral. Sifting property of del t. So the sifting property, it says that from 0 negative to 0 positive, when any integral which is a product of a function of ft with del t is evaluated from 0 negative to 0 positive, then this gives the value of f of t at 0, right? So this integral here, as we have seen that this is 0 elsewhere other than at t is equal to 0, so we can rewrite this integral as Laplace transform of del t is equal to 0 negative to 0 positive, because it is 0 elsewhere, right? It only has a value it is at t is equal to 0. So we can rewrite this integral as 0 negative to 0 positive. So del t e raised power minus st dt. So if you compare it with here, so this will give the value of this function at t is equal to 0, right? So we can simply write the Laplace transform of unit impulse function. The value of this e raised power minus t is equal to 0 is e raised power 0, which is 1. So the Laplace transform of unit impulse function is 1. So one more thing to note about the unit impulse function is that if we integrate it from minus infinity to t del x, this is dummy, right, variable dx. So it will result in a unit step function, right? This variable t appears here, then this is dummy variable. So this will give us a unit step function, and that unit step function is basically equal to 0 for t less than 0, and it is 1 for t greater than or equal to 1, right? And if we differentiate this unit step function, this will give us the unit impulse function, right? And the unit step function is, it can be brought like this. This is t, this is u of t, this is origin 0, and it is 0 here, and here at the origin it takes on a value 1 and goes on like this, right? So this is, for example, 1, 2, 3 and so on. This is -1, -2 and -3 and so on, right? This is unit step function. So the Laplace transform of a unit impulse function is 1, and if we integrate a unit impulse function, we get unit step function, and if we differentiate unit step function, we get the unit impulse function.